All right, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing unassemblize tool, and I can't remember what we did in the last video. We have no pending changes. Print executable file names. Okay. Okay. Yeah. Let me think. So there's still stuff to do. There's still stuff to do. Okay, I think first thing I would like to is a mismatch. Is a mismatch. Label. Okay, so basically I question if we should use std_get because it makes assumptions. So for example here, look at, okay, so for example here I would say we do look at so for example here I wonder if we should do this. Get if and then we put a then here we put a else assert false. Same here. Same instruction. Instruction get if. Else if that instruction variant get if, then here we do else assert false. So at least we won't crash, you know. Okay, and then we also have this. Yeah, I would also say get if I also put it as instruction 0 is not null pointer. Okay. Okay. Hold on. I think maybe there's also a different way. Can we say is it possible to assert instruction dot no variant wait std std gets holds alternative. I think we should use that instead. Yeah. Let's revert those changes. So we do assert std holds alternative. How do we write that? Holds alternative ASM instruction variant 0. Yeah, let's do that. I think that's better. Add assert before all unchecked variant accesses. Okay, I have to say that the the Clang format is absolutely atrocious. I don't know how people can work with that. It's so bad. Clang format, brackets on new line. Break before braces. Custom. Break before inheritance, comma. Break constructor initializes after colon. What is this brace wrapping? Okay, after class. True. Before else. True. Indent braces. What? Before catch. True. Let's see what that does. Oh, look at this beautiful code. This is how it should look like. Oh my gosh. How I miss beautiful code. Okay, so we need to go through all files. And update the formatting. Unfortunately, I don't know how to automate this. Runner. Okay. It's much better to read, yeah. Yeah, I don't understand why people do this compact stuff. Compact code is so hard to read. So hard to read. Yeah, look, this gives so much more space to read. It's much better. Yeah. Does mean we need to scroll a little bit more, but I think that's okay. Good. Then change brace wrapping in Clang format for better readability of code. Change brace wrapping format. Okay. Okay, what's next? What is next? Okay. So right, there was one more thing in executable, no, in PDB reader that I noticed yesterday. One of these things is not being reset on unload here. Release. Let me see, dear session. Git global dear Git global scope. Git global scope. Okay, looks like we can simplify this. Oh, we just do that. Deassemble. Put breakpoints. Co-create instance. Co-create instance. It was problems. The question I have is if this needs to be released in any special way or not, or it's just thrown away after co-uninitialize. I don't know. So here we call this. Maybe. I don't know if that's correct. So this name. Okay. Deassemble git name. Reads global scope. Get global scope. It's not much info here. It's not much. Executable name. Idea symbol executable name. Yeah, that doesn't help me. Underlying executable file. Get name. I don't know. I find it extremely odd that the executable supposed name is just Thyme and not Thyme.exe. So I think we do it wrong. Exe executable name. Exe name. Nothing. Global scope. Exe. Get global scope. It says name of the exe file, but it's not true. It gives us Thyme. It's lying. But I mean, if it says so, I don't know. I have no clue. I would say here we put a if pass dot has extension. If not has extension, then we append exe. Is that fair? Yeah, let's do that. I don't know what's up with why it's not giving us exe, but I find it weird. Okay. Good. So yeah, reasons. Okay. Minor tweaks around PB reader class. PDB reader class. Good. Next. Next, I would like, yeah, okay. So there is question mark about, so here in our comparison, let me see, let's find an example. Okay, here's an example. So as you can see here, it claims that these are equal, but we don't really know, right? Because the names are just placeholder names, unknown symbol names. So it is a maybe match. It's a maybe match, but we currently don't have this concept of maybe match. We just have mismatch, match. That's it. So I wonder if we should introduce a maybe match in our ASM matcher types here. So we have match, and we could have a maybe match. Match maybe. Yeah. Match maybe. Match maybe. And this would it would also give us this text mismatch info. Or we classify it as mismatch, but in the mismatch info we add another info here. We have a bool mismatch bits. Let's put a static asset size of searching for smaller than 8. We say we create another. We say maybe mismatch bits equals 0. Then we add a new function, bool is maybe match. const return is maybe match. So what we can say, we it makes things complicated. Mismatch info. I need to look a little bit around as a match. So it is, when we do the look ahead comparison, then we do this, if not has mismatch. Mismatch. I don't like if we do this here. Shit. So right now we have like a really clean separation, right? It's a match or it's a mismatch. It's a match or a mismatch. But if we add now here conditions in here, like, oh, it is maybe not a mismatch if you consider this and that. Like, then you water this thing, right? It doesn't become a mismatch anymore, and then it has like multiple meanings. I don't like that. Shit. Let's see, where are we using this? Match maybe. Match maybe. I don't know. So basically, if we would do it here, then we would make this 0. So this is definitely a match. Is maybe match would mean that this has to be 0. And this is not 0, then it's a maybe match. And this mismatch is maybe mismatch. Is that true? Is maybe match is true if mismatch bits are 0 and the maybe mismatch bits are not 0. Then it's maybe a match. Is maybe a mismatch is maybe mismatch is the same as maybe match, right? Or am I tripping? If it is maybe a match, it can also maybe be a mismatch, right? That it only depends on how we look at it. Or am I wrong? Maybe mismatch bits 0. Bits representing positions where instructions are mismatching. Maybe mismatch bits. Yeah. Yeah. Instructions are maybe mismatch. Okay. Maybe mismatch. Okay, so this I guess works. And then we know, aha, okay, it's definitely mismatching, or it's maybe mismatching here and there. So this would work. But then the problem is we have this ASM mismatch, and it has more than one meaning. Like, yeah, but maybe it's fine. Like, we know ASM match is a definite match. Crystal clear. But ASM mismatch. ASM mismatch. Okay, so basically we would classify anything that has one of these not 0 would be classified as a mismatch. What we could also do is we could combine ASM mismatch and ASM match into one. Like, there is not much reason to have these apart, right? Because in the end, if we have this guy, we can also just check if it's a match or a mismatch from this info thingy, right? But this one, but this doesn't tell us. Yeah. Where jump, then mismatch, false. Yeah, we could do that. ASM label. ASM instruction label, ASM instruction. Label, match. Okay. Okay, so we could, let's rename this to ASM label pair. And then we rename this to labels. And then we call this ASM instruction pair. And we call this instructions. Well, we call it pair. Pair. And this as well, pair. And then we rename this to ASM text, ASM text info. Or ASM mismatch info. Okay. And then isMatch return not jumplen mismatch. isMatch maybe. And not jumplen mismatch. Okay. ASM label pair, instruction pair. Then we simplify this to label, ASM label. And we remove this and we remove, well, let's see if it still compiles now. It should compile. We did a lot of renaming. Yeah. And then we remove this one here and this. Okay. And so we would only use this here. And we call this mismatch info. Instruction pair mismatch info. Okay, so basically the deal would be now we don't have like an ASM match and ASM mismatch variants, but just the instruction pair. And then in the instruction pair we can check the status of the match or mismatch, or maybe match, maybe mismatch. Yeah. Maybe that's better. Maybe that's better, yeah. It's also closer to what they reference. So here, this label pair reference twice ASM label. And this references this. Yeah. I think I like that too. Yeah. It will make the ASM printer easier, because then we can get rid of some code duplication here. Here. Can simplify this because they do similar things. Okay, let's see how this will go. First we need to look at ASM matcher. Yeah, this will be interesting. Okay, so ASM mismatch. Okay, so here we have ASM match. ASM match. ASM. Let me go back to match types. Okay, so this is all initialized to 0, and all 0 means it is a match, right? Okay, that's good. Then let's go to printer. No, mismatcher. Instruction is matching. We do that. Match. Okay, let's call this is let's call this just instruction pair. Instruction pair. And this one will also be instruction pair. Rename instruction pair. But we count up the mismatch. Mismatch count. Let's add another count here. Maybe mismatch count. Or maybe match counts. Alias maybe mismatch. Could be a match or mismatch. Then we put this here. Okay. Okay, so we have instruction pair. Mismatching. Let's rename this to mismatch info. Mismatch info. So mismatch info. Mismatch bits. It's missing instruction once. Mismatch info. Has mismatch. Okay, so I'm wondering, perhaps we can simplify all of this. Let's put null pointer here. Okay, how about we do the following? We do this. Then we do if instruction 0 is not null pointer, then plus plus I0. If instruction 1 is not null pointer, then plus plus that. Let's do assert is matching or instruction 0 is not null pointer. Is matching or instruction 1 not null pointer. So this means if it is not matching, then no, hold on, not is matching. So if it is matching, instruction 0 and 1 cannot be null pointer. You can probably simplify it. It's not matching or instruction 0 is not null and instruction 1 is not null, right? Place. Okay, then we also have this here. And then we say if mismatch info dot if is match so if is match, then we count up this, else if is maybe match, then we do plus plus result dot is maybe, wait, maybe match count, otherwise is mismatch. Mismatch count. And with this, I think we can replace all this. Your instruction pair. Let's put this into a scope. Yeah, I think we can do that. So if it's not, if it's not matching, then we expect that these guys are not null pointer. Otherwise, one of these can be null, which, yeah, then we no longer put dummy instruction, but we actually put null pointer, which is fair. And if it's not null pointer, then we count these up. Yeah, I think this would be pretty good. Okay, this is a nice simplification. I like that. Okay, let's get to the next thing. instruction. I think it also means that our instruction variant, that we can remove the null instruction here, I think. Because it's currently used. No, we still need it. Let's put it back. We still need it. Yeah, we just call it ASM null. ASM null. Let's put it at the end. Yeah, let's put it at the end. ASM null. Okay. I think we are going in a good direction. And if not, we just revert it all. Right? Okay, so then we say text info mismatch bits. Right, so this is ASM instruction pair. Did we call it instruction pair down here or not? Yeah, instruction pair. Then let's do the same here. Instruction pair. It's pair. And we rename this to mismatch info. Okay. Mismatch bits. Okay. Opposite side is null pointer. Okay. Okay, everything is green in here. That's good. We still have dummy instruction label. How about we remove that as well? We make this null pointer as well. So we put is okay, run comparison. So here I do so we do if label 0 is not null pointer, then plus that. If label 1 is not null pointer, plus I1. And then here we do ASM label dot pair 0 equals label 0. Same for 1, label 1. Yeah, and then we can remove all this stuff here. Yeah, I think that is better. Yeah. Okay, so ASM matcher is served. Now let's go to ASM printer. It's actually not so much code that we are changing. I thought it would be more. Okay, so basically it will always go in here now. No longer in here. Okay, so we can consolidate the logic. First, we need to say here, label, do here label. If label is not null pointer, then to string label. Yeah. And here we say ASM instruction, instruction, instruction is not null pointer. Yeah. And here instruction address, and here dereference. Okay, that's cool. I think then we can also remove the isEmpty function, right? I think so. Yeah. Okay, so here equal, unequal, left missing, right missing. Yeah. Okay. We need a new equal, unequal. Let's do a new, maybe equal. Let's put 2 question marks here. Maybe equal. Okay. Equal, maybe equal. Okay. And then maybe equal. Okay, so we need to merge this stuff now in here. How do we do that? Let me see. Address. Da, da, da. Pad sideline. Pad sideline. Okay. Okay, before we continue with this, we still need something else. There's something else. Let's get to ASM matcher. Here, compare ASM texts. So, actually, let's do it last. This probably requires the most brains. Let's get back to ASM printer. Okay, so instruction, good. Pad number. So basically, all this is the same. So just this is different here. This. Okay, so here we say if instruction, no. Let's call this instruction pair. Instruction pair. So if instruction pair mismatch info dot is match, then is that, right? Is match. Else if is maybe match, then we do line buff append maybe equal, and else if is mismatch, then we do this here. Write instruction pair, instruction pair I plus 1. So here we say instruction if if instruction if instruction is not null pointer, if write instruction is not null, okay. If this one is null pointer and write instruction is not null pointer, otherwise left not null pointer, oops, null pointer, and write instruction not null pointer. Okay, right missing. Oh, hell, that's wrong. Right. Okay, there we go. Okay, and then we can remove all this. I think that is not bad. Okay, so now we have the concept of maybe match here in our printing. And then what we can do as a next step afterwards, but we don't do it now, that we say you can configure to say a maybe match is treated as a match, or it is treated as a mismatch, right? So, or as like a display as maybe equal. So you can switch between three states. You can selectively say, okay, I want it to be treated as a mismatch or as a match. I'm more lenient, I'm more strict, right? So it then gives you more options to like have a lenient comparison or a more strict comparison. But there is still one thing we need to do and one thing we need to check. Okay, so I think this will compile for now. Let's see. Yeah, it compiles. Okay, let's go to ASM Matcher. And mismatch info results. This section is mismatching break. Right, okay, so okay, skip unknown symbol, skip known symbol. Okay, so here we say if at least one symbol was skipped, then this quote is done. And this also means if we skip one, if we skipped an unknown symbol on either side, then we know that this is a maybe mismatch, right? Maybe mismatch bits. Yeah. In quote. I think here we can actually also put a continue, no? Because down here it would just check this and it will be equal because both will be quotes. So might as well just continue, right? I think this is correct. I put the assert here. Maybe mismatch. Yeah, I think that's all we need to do. Well, that was simple enough. I thought it would be more complicated, but there's still more. There's still more to consider. One more thing. Let's put a breakpoint here anyway. I want to check. So compare ASM ticks. Has mismatch. Let's rename this. Let's search for all text infos. Let's mismatch info out mismatch info. So So has mismatch. Okay, here's an interesting question now. Has jump lane mismatch. Oh, we also need to set this guy. Hold on. Mismatch info. Mismatch has. Yeah, let's put this here. And then has jump lane mismatch info. Let's simplify this down here to that. Let's put this down here. Has jump lane mismatch info dot jump lane mismatch equals that. Okay. Mismatch info. Let's go to mismatch info. Jump lane mismatch. Let's rename this to has jump lane mismatch. Bool has invalid mismatch. Okay, and not has invalid mismatch. Not has invalid mismatch. Yeah. We should give this a different name. Has validity mismatch. maybe that's better. Okay, so here we need to mismatch info dot has validity mismatch true. Here we do else. Else move this here. That's nice. Mismatch info is mismatch. Okay, that's good. But now there's a question here. Has mismatch. Has mismatch. Has mismatch. Mismatch info dot has validity mismatch true. Has mismatch. Instruction. What I can also do is if instruction or that how about we simplify this to not match info has validity mismatch. Instruction 0. Has mismatch. How about we accept pointers here? So we say if if instruction 0 is null pointer or instruction 1 is null pointer, then has validity mismatch. And then we accept here pointer. Text. Okay. Say else if okay, so it covers like really all the cases now. Yeah, and that means we can then remove this here. And we just pass that. We need a distinction. Mismatch bits 0, maybe mismatch bits 0 has jumplen mismatch false, has validity mismatch. Let's create a enum mismatch reason flags or mismatch reasons. Int mismatch reason jumplen equals 1. So validity jumplen validity Maybe validity. Mismatch reason null. Oh, it's missing. Invalid jump len. Yeah, I think that's good. Okay, so instruction is missing on on one side. Instruction is invalid on one side. Jump length is different. Okay, int mismatch reasons. Zero. We do mismatch reasons equals 0, 0. There we go. Instruction is missing on one side, instruction is invalid on one side, jump length is different. Yeah. Oof, things getting extra complicated. Okay, so do look ahead if we can also get rid of this here, by the way. Mismatch info dot mismatch reasons and is mismatch info mismatch reason missing. It's not 0. Do look ahead. No, yeah, it's not 0. No, wait, it's 0. Let's put a breakpoint here. It's missing instruction on one side. No look ahead if instruction is missing on one side. Okay, instruction is missing on one side. Now the question is, do we also still need is matching? Because mismatch info. Mismatch info. If has mismatch. If has mismatch, yeah, is matching true. Do look ahead. False. Is matching true. Mismatch info. Mismatch info. Okay, I think we can simplify this more. We're taking out the trash right now. We really do. So instead of this assert, we can say assert mismatch info.isMatch. And down here, we can also say, here we mismatch info dot is mismatch or that. Yeah, I think this means we can get rid of this is matching thing pretty much. Further simplification. I like that. Okay, do look ahead. Then I think it also means we can remove this because the default, well, it's okay to be explicit here. Not a big deal. Yeah. Okay, this might be correct or no? Set new base index and break. Aha. Alright, switching. Okay, if look ahead result is matching. Look ahead comparison. Okay, we need to look into that as well. For now, what we can do, we have our mismatch info and we set our mismatch info to ASM mismatch info, just reset it essentially. All back to 0. Set new base index and break. Yeah. Okay, we still got problems. Right. So here we say mismatch dot mismatch reasons, and we set flag mismatch info mismatch reason missing, and here we set mismatch reason invalid, and here we set if has this, then mismatch info jump len. There we go. Okay. Yeah. I wonder if I made some mistake. It's possible. Right, this function. Yeah. So run look ahead comparison. What's the problem here? Oh, right. We need to still pass pointer. Yeah. Okay. Okay, but there's still one more question. What do we do? So let's say something has maybe mismatch, right? Well, maybe match, which is the same. Maybe match, maybe mismatch is the same. How should the look ahead logic behave in that case? Should it look ahead if it's maybe matching, or what should it do? So right now it will consider a maybe match as a match for the look aheads, right? The question is, should that be any different? I don't know. I don't know. And this is also wrong then here, this. Because here it makes the assumption that not has a mismatch means it is matching, but it's not true. Yeah. Okay, so here we have an error. Look ahead result. Instruction. Okay, I already know how to fix this particular thing here. That is not the problem, but has mismatch. How do we deal? So it is a maybe mismatch, right? So hold on. Okay, before we continue, let me really quickly fix one thing. So here at the look ahead results, which is very short right now, is label is matching. This label is matching. Let's in our look ahead results. We need a ASM mismatch info. Mismatch info. 12 bytes, alignment 4. How about we make this also UN64, UN16. Then it's 6 bytes. Then this will be 8 bytes. Very much smaller. Mismatch info. Okay. So basically, we pass here let me yes, mismatch. Why don't we change this here? Yes, mismatch info. Why don't we make this return this, which we can do now happily, like that. Has mismatch. Let's go in there. Has mismatch, mismatch info, return. Let's rename this to get mismatch info. Or create mismatch info. Okay. So mismatch info equals that. If mismatch info dot is mismatch, then that. All right, remove that. And here, mismatch this. Look ahead results. Mismatch info equals that. Create info. This. If look ahead result mismatch info dot mismatch. Okay. And then, yeah, so basically we return this now. Let's search for where we call this. And here we say, look ahead results. dot mismatch info dot is match, and then we assign this. Well, I think the way it was before was also legal. I mean, this will be just null everything inside. No, not true. Right, we need to do it like this because of the maybe. Hold on. Hold on. Right. Right, okay, so, okay, let's, yeah, okay, we have still a problem. Shit. So is match means that we don't move ahead if it's maybe match, right? So let's say if not is mismatch. Not is mismatch. Not is mismatch. Okay, so now it will basically do the behavior we had it before. If it's a maybe match, we stop the look ahead and we are satisfied and it's okay. Which I guess is fair, but we could also have a different condition and say if it's a maybe match, then we don't accept it and we look ahead, we keep looking ahead, right? Yeah. So right now we have this condition here, and this condition must match the condition inside of here. How about we unify this? Look ahead results. Bool is quasi matching. Or let's say is considered matching. False. Could be true if the, look ahead, hit label, hit the label. Look ahead is considered a match. It could be a maybe match. Okay. And then we put look ahead results dot is considered matching equals true. And then here we say is considered matching. Yeah, let me use the same here. I think that's better because now it uses the same the same condition. It's considered matching. And then here we use look ahead results, mismatch info. Okay, let's compile this. Also, let's go in here. To do should make this configurable to skip ahead on maybe match question mark. Yeah, I don't know the answer. Maybe maybe it is desirable to have the option like if it's mismatching, yeah, then don't consider it as match here. So if is maybe mismatch is considered to be a mismatch, then it shouldn't enter this. If the user would desire this behavior, right? Maybe. I don't know. Let's keep it like this. So this was legacy behavior, and that should be okay. Good. Let's compile. Okay, compiled successfully. There was a lot of changes, quite a bit of refactoring, cleanup, but it's not bad. I think we got rid of a lot of dirt. That's pretty cool. I am a bit nervous here about some things. There could be some bug maybe. Let's run this. Let's see if we get some crashes or not. Oh, we get a assert. Let's see, what is it? Huh, we have seen this before, no? Instruction next, instruction con. What do we call this on? No, we haven't seen this before. Okay, I have no idea why this happens. Let's run it again. Huh, no, it didn't hit. Well, that's weird. Okay, so match info, let's see how it looks. Mismatch bits 2. Yeah. Create mismatch info. Let's put some breakpoints in here to see that things still work okay. Oh. Ah, mismatch. Huh? Do look ahead. True. Is matching false. Okay. Is match. Do look ahead. Wait, what condition was there before? Oh, is matching false. I see. Okay, so here it should be assert not is match, right? Not is match. Yeah. Okay. Okay, I have no idea what's going on here with these instruction counts. I suspect this is because at the end here we get some random instructions, so maybe we should set this to 6F 6F yeah, let's do 6F00. Okay. Okay, so here we got that mismatch info, mismatch bits, jump len mismatch, mismatch info. Yeah, okay. Look ahead, true. Look ahead, not a match. Yeah, this is much easier logic now. That's good. Yeah, I like it. I like it. Okay, here we got a maybe mismatch. Let's see. It was a unk and this. Yeah, it is a maybe mismatch. Yeah. There is one problem. I think with jumps, we look for lock, right? Lock, LOC. But these will never, they will always be different. So I think for these, we should not consider maybe mismatch. That we still also need to do, yeah. Let's see if we hit such a case. Here we have an off, that's fine. Let's take our watch and put word in there. Okay, so here we got off, and so on. But we should get some here, lock. There we go. This one should not be considered maybe mismatch. Yeah. Okay, how do we do that? Skipped. Skip. Yeah, I have an idea. And I also realize something here. This one will skip ahead symbols that are not of the same, it will skip ahead prefixes that are not of the same type. So it would skip ahead a of and a zup. Like let's say word 0 would be zup underscore something, and word 1 would be off underscore something. Then both would skip ahead, but they wouldn't be the same thing, right? So I think we need some improvements here. The more we think about this, the more we realize. What's the time? 2 hours 30. I think a break would be great. Yeah. Let me put some to-dos here before I to-do do not mismatch on lock, and here to-do skip. Do not skip do not skip do not skip mismatching prefix. Yeah. Okay. We have still some things to do. Good. Yeah, but it shouldn't be a problem. Okay, I will take a break now. And yeah, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.